In today's lessons, we're going to talk about how to tell if compositions are commutative or not commutative. So first, the word commutative just means that it is an operation that gives the same answer if the order is reversed. For example, adding is commutative. Anytime you add, it's commutative. So 2 plus 4 is 6. 4 plus 2 is 6. So same, different order, but they give the same answer. So that's commutative. So when we talk about compositions of functions, sometimes they are commutative, sometimes they aren't. It just depends on the equations, two equations that you're given, right? Generally, they're not equal. More often than not, they are not the same, and they're not commutative. But sometimes it does happen. So what we're going to do today is talk about how do you know if they are or not. So basically, all you do is test both directions. So do f of g, get an answer, then do g of f. So swap the g and the f, see if these two answers are the same. So in this example, they're not the same, so they're not commutative. Right? So we're going to practice. Now here's two functions. Didn't work. That is supposed to be under it. Okay. So what you do is you do two things. First, you do f of g of x. Then you do g of f of x. We have to test both. So let's test the first one. So we're doing f of x plus 3 over 2. So we're plugging x plus 3 over 2 in for x. So here it's 2x minus 3. So I'm going to take away the x. And in its place, I'm going to put this. Right? Then we're going to simplify. So something nice happens here. The 2's will cancel. I'm left with x plus 3. And then that minus 3. Like terms, 3 minus 3 is 0. So the final answer is x. Right, so f of g of x equals x. So now we'll try the other direction. So now we'll do g of 2x minus 3. So in g, where that x is, so this x, we're going to put this where that x was. So instead of x plus 3, it's 2x minus 3 plus 3. So first, like terms, negative 3 plus 3 cancels. I get 2x over 2, which reduces down to x. So you see that both answers were x, which means the answer to the question, are they commutative, is yes. So they both came out to the same answer. So in this one, we've got f of x is 2x squared, g of x is the square root of 3x minus 1. So we do f of g of x first. So f of the square root of 3x minus 1. So in f, we're going to take this and plug it in for x. So we've got 2, and then the square root of 3x minus 1 will go where the x was. Remember that if you're squaring a full square root, they cancel. So all I really have is 2 times 3x minus 1. It is 6x minus 2. Okay, so we did f of g of x. Now we'll do g of f of x. Test that one, which would be g of 2x squared. So we'll take 3x minus 1, take out the x. Right, so you see there's a space here where the x was. And we'll put the 2x squared in that space. So what we do is 3 times 2x squared would be 6x squared. Since we can't take the square root of all of this, that just means that's the final answer. So compare this to that. They are definitely not the same thing. So this one would not be commutative. Right? Not commutative. I've got one more example. So what I want you to do is pause, give it a try, and then unpause, see if you got it right. Alright, so pause the video. Okay, so we're going to try f of g of x first. F of 3x plus 2. So in the f function, we'll do 2, take out the x, and put in the 3x plus 2. Be 6x plus 4 plus 3 is 6x plus 7. Now g of f of x. So put f of x in here, 2x plus 3. So in the g function, I take away the x, leave a space, and put in our f function. 6x plus 9 plus 2 will be 6x plus 11. Right, compare. They're very close. They both step the 6x, but they have a different number there, which means this one is also not commutative. If you have any questions about the lesson, you can send me a message on Remind or